Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 34, Acid-Base Equilibria Part 3. Here are our objectives for today's video. Pause here. You do not need to draw the pictures. So we've done tons of titrations in this class, some of these with acids and bases, some with redox. Most of the ones on the AP exam are usually acid-base titrations. And we've typically used a pH indicator to figure out where the equivalence point was, or just the stoichiometric equivalent. But a more precise way to do these would be to create a titration curve, which is where you take a pH meter, a pH probe, and you stick it inside of your Erlenmeyer flask, and you're actually measuring pH over the amount of milliliters of typically the NaOH is what we've done in this class. You plot pH versus milliliters of base added, and this is able to give us a tremendous amount of information. In this video, we're going to focus on just strong acids, strong bases, which is the simplest case, and then we'll expand upon this with weak acids and weak bases where you have to throw equilibrium in the mix. Pause here. All right, I'm going to work through this, so this should be something that you know how to do. It would be equally correct to say H plus OH minus forms H2O. Either way, so long as you're forming water. This is not an equilibrium reaction, so I just used the forward arrow. Since we're just forming water, the pH at the equivalence point will be 7. Pause here. You could just do a very rough sketch of the picture. So this is what you could typically expect to see if you're titrating a strong acid with a strong base. So there's a couple of characteristics to these sort of graphs. So we first see a slow rise in pH, and then there is a sudden jump. And in the middle of the sudden jump, it's sort of like an undefined function in math. There is a point that is along that line where you're going to find the equivalence point. And for a strong acid, strong base titration, that will be at a pH of 7. Since this is not an equilibrium reaction, the way that you're able to, let's say, predict the pH changes would be just through some stoichiometry sort of calculations, figuring out before the equivalence point how much H plus you have, taking the negative log of that, and after the equivalence point, figuring out how much hydroxide is left over, converting that to POH, and then converting that to pH. Pause here. So this might seem to be pretty simple or even redundant, but it's going to become a little bit more complex with the weak acids, and that's why I'm including this here. So before the equivalence point, H plus is going to be dominant, or H3O plus, however you want to call it. And when I say dominant species, I'm not including water here. At the equivalence point, there's no dominant species in a perfect experiment aside from water. And then after the equivalence point, OH is dominant. It's the dominant species that really determines the pH, and that's why it's important to understand. Right, here are the practice problems for today's video. Thank you so much for watching and have a great night.